Hi everyone, welcome to my AdMth channel. Today we do a coordinate geometry masterly practice. Let's read the questions. In the diagram on the right, POQ is the graph of y equals to modulus 2x. R is a point on OP such that OR equals to square root of 45 units and O is the origin. Okay, so this one is modulus 2x. When this is modulus 2x, so this means that, okay, this one will be, this one equals to 2x, and here will be negative 2x. Alright, okay, so R is a point on OP such that OR equals to square root of 45. So here square root of 45 units. Okay, O is origin, here is origin. RS is perpendicular to OP, RS perpendicular to OP, and OR is parallel to TS. Okay, OR parallel to TS. Find the coordinate of RS and T and the area of trapezium ORST. Okay, let's find the coordinate of R first. Okay, so first of all, we need to find the coordinate of R. Let me write down here the coordinate of R. Okay, so to find the coordinate of R, so we know that our equations OR is y equals to negative 2x. Okay, let's our coordinate R here equals to x and y. Let coordinate R equals to x and y. So it means that when coordinate R equals to x and y, it means that here is x and here will be y. Alright, so from xy here we notice here. Okay, this is a Pythagoras theorem. It's a right angle triangle. So therefore, okay, let coordinate R equals to x and y. Okay, therefore our square root of 45 square is equals to x square plus y square. So 45 equals to x square plus y square. From the equations, we know that here y is equals to negative 2x. So 45 is equals to x squared plus negative 2x squared. So 45 equals to 5x squared, and our x squared is 9, whereby our x is positive or negative 3. Okay, so here is negative side, so this one should be negative 3. Alright, so when our x equals to negative 3, okay, y equals to negative 2 times negative 3. So we have 6. Therefore, our coordinate of R is negative 3 and 6. Okay, now we proceed to coordinate S. Alright, let me move here. Okay, so I write down the coordinate of R first. Our R coordinate here is negative 3 and 6. Okay, so since our S here is perpendicular to y, so therefore we can use the gradient functions. Okay, so let's try coordinate S. I write here coordinate S here. Okay, from OR we find that our gradient of OR. Let's try gradient of OR. So gradient of OR is 6 minus 0 and negative 3 minus 0, which is negative 2. Since OR is perpendicular to RS, therefore, okay, gradient of OR times gradient of RS is negative 1. So we have negative 2 times gradient of RS, which is negative 1. And gradient of RS is negative, positive 1 over 2. Okay, So let's try our equations of RS. So we have gradient already and we have a coordinate. We can try equations of RS. So equations of RS, y minus y1 equals to gradients times x minus negative 3, positive 3. So therefore 2y equals to x, okay, plus 3 plus 12. So 2y equals to x plus 15, and y is equals to 1 over 2 plus 15 over 2. When for coordinate x, for coordinate s, our coordinate x of s is 0. So when x equals to 0, y equals to 15 over 2. Therefore, our coordinate s is 0, 15 over 2. Here. Alright, so now let's proceed to coordinate t. Okay, coordinate t. Okay, for coordinate t, you have to aware coordinate t here, ts is parallel to our OR. So when it's parallel, it means that the gradient will be the same, right? So let's find coordinate t. Okay, for coordinate t, coordinate t here. Okay, since RO is parallel to ST, therefore our gradient of RO is equals to gradient ST. So which is gradient of ST is negative 2. Okay, it's negative 2. So we find the equations first. Try to find the equation. So the equations of ST. Y minus, I use coordinate of S. Y minus y equals to gradient times x minus x. So we have negative 2x plus 15 over 2 equals to y. Okay, for our coordinate of t, we need to find coordinate of t, right? Okay, so for coordinate of t, which is the intersection between this ST and our coordinate t here is ST and OQ, right? So intersection point. Now we find coordinate t. Okay, so y equals to 2x. Y equals to 2x is our equations of OQ and ST. Okay, so y equals to 2x is our first equations. Okay, and y equals to negative 2x, which is ST. 15 over 2 is our second equations. So we use the substitution method. 1 equals to 2. Okay, so therefore 2x equals to negative 2x plus 15 over 2 to find coordinate of t. So 4x equals to 15 over 2, and our x is 15 over 8. When x equals to 15 over over 8, our y will be 2 times 15 over 8, which is 15 over 4. Therefore, our coordinate of t will be 15 over 8 and 15 over 4. Okay, so let me write down the coordinate here. Okay, coordinate t is 15 over 8. Another one, 15 over 8. Another one is 15 over 4. Alright. Okay, so we settle 3 coordinates. So coordinate of R, we have negative 3 and 6. coordinate of S, we use the perpendicular gradient functions. We find out S is 0 and 15/2. For coordinate of T, we use intersection point between two lines. We find that T equals to 15/8 and 15/4. Okay, so now we proceed to part B. Part B is asking the area of trapezium ORST. Alright, so now I do this one here. Okay, part B. Okay, the area of trapezium ORST. Okay, so the area equals to, I use the coordinate polygon coordinate point. Okay, so 0, 0, x, R is -3 and 6, and then S is 0, 15/2. Okay, and our T is 15/8, 15/4, and 0, 0. Okay, so we use this method to find our to calculate the area. Okay, so now let me show you. Okay, so this one we multiply plus, and another one, give me a minute. Okay, like this. Alright, let's do this. Alright. Okay, so we have here, okay, 1/2, 0 times 6, 0. Here, -3 times 15/2, we have -45/2. Okay, so here 0, 0, okay, minus. Here, -0, -3 times 0, 0, 6, 0, 0. So 15/2 times 15/8. We have negative, alright, minus, we have positive. Positive 225/16. Okay, so now we do the arithmetic. So we have, okay, negative here. Okay, so we have, so we have here, what we have is, here we have 18 and 9/32 square units. Okay, thank you for watching. See you guys in my next video.